All right, people. So today we're going to be covering root mean square velocity. It's a very simple problem. What this problem does is it uses what we talked about on the last video, that the kinetic energy is equal to 2/3 r times t, and it derives um an average velocity for this problem. I'm not going to show you the derivation, right? Like, you know that 1/2 mv squared is kinetic energy. You set it equal to 2/3 RT, multiply both sides. Um, ugh, just let's not do this. Let's not do this. Anyways, from this equation, you get this one. Let me explain the portions of it. Big M. Big M is the molar mass of your gas. All right, and the R is the other gas constant, 8.314, and this is now joules over molk, moles times K, and then T is temperature, right? T is temperature in Kelvin. All right, now, why do we use what's called a root mean square velocity? Well, the assumption was that all gas particles are constantly in motion, that they don't lose energy, but in reality, in practice, gases all are actually moving differently. If you take a look at this little diagram, figure 5.119, this is just a sample of what the path would look like for a single gas particle. So imagine it started here, it goes straight, crashes into the wall, crashes into something, launches it here, bounces there, and it just kind of bounces off, and it moves throughout this whole thing. It would be completely incorrect to actually say that the particle stays the same throughout the whole time. So instead of saying that it is the same, what you do is you assume, or you take an average. You always take an average, because if you're thinking about some particles, if you remember what I said in the last video, that some particles are barely moving while other particles are moving super fast. But the majority of the particles will fall under this area of the curve. So majority of the particles will be moving at an average. So you take the mean, you take the average, so that you can find the velocity of a gas. So let's go ahead and let's do that. So the root mean squared of a gas is equal to the square root of 3 times R, which is 8.314 J over molk, moles times K, and then times the temperature. So the temperature for this problem was 25 degrees, but you should already know that's 298 K. Now let's keep moving that root. And then M, big M, is the molar mass, but it is in kilograms. Do not forget that. So if we are talking about a helium atom, and the molar mass of helium is 4 grams per mole, let's turn that into kilos. And we know that 1,000 grams is the same thing as 1 kilogram. So we're basically dividing 4 by 1,000. So it becomes 4 times 10 to the negative 3 kilograms per mole. And then we put that into our problem here. And then I gotta lower that little square root, because there's someone who's gonna be like, Mr. Sanchez, I didn't like how your square root thingy, whatever it's called, well, I didn't like it either. All right, there we go. There we go. All right. So let's take the square root of it. Sorry for yelling. I didn't mean to yell. If it hurts your ears, I'm sorry. 3 times 8.314 times 298. Uh-oh, I got to divide by 4 times 10 to the negative 3. So I'll put 0.1, 1, 2. All right. And I get 1.192, and I'm going to check my my math because why is my math wrong? Oh, there's a 5, 8.3145. So 3 times 8.3145. Oh, I know. There was a little mistake. My finger slipped and it pressed something. Times 298 divided by 0.004. All right. And then you got to take the square root of that. Hello, square root. What the heck? Why is it? Well, whatever. The answer you end up getting is 1.36 times 10 to the negative 3, or times 10 to the third. And the units are meters per second because it's a velocity. It's a velocity. Mean squared is a velocity. Something's off with my phone. Let me start again. 3 times 8.314 times 298 divided by 0.004. Okay, we're over there. Are we correct? All right, 1.8 times, and then we take the square root. Let's take the square root. Okay, I did get that. All right, for sure. I was just I think my fingers are a little too fat, so they kind of messed me up. All right, so that's basically it for these types of problems, and we can. Did I have another one of these? I thought I had 2 of these problems, but this is basically it. Root mean squared. Yeah, that's it. Super easy. You're welcome. I guess. I don't know.